I get a lot of questions about why didn't you just decide to use Excel for this class? Why this R thing? So I want to walk you through just a really simple task, and I'm going to do it both in R and in Excel. And this is basically the things that you'd have to do to compute a standard deviation, but that's not important. I just want to look at the differences between R and Excel. So the task is to start with the integers 1 through 10, compute the mean, compute the deviations from the mean for each value, which we could call the errors, square the deviations, compute the mean of the squared deviations, and take the square root of the mean of the squared deviations to get what is commonly called the root mean squared error. You can see where the term comes from. Okay, with that mission in mind, let's start. First, I'll go over to Excel. I want to get the numbers 1 through 10. So I'll put X up here to keep track of what this thing is. And then I could just write the numbers 1, 2, 3. Actually, Excel has a neat characteristic. If you select a collection of cells, and they sort of have a pattern, you can see that they're going up by 1, and then you can get to this little thing in the last one of those cells, and then hold the your left mouse key down, and just you can go down as far as you want. I only want to go down to 10. Okay, so there I see 10. Okay, so that's the way I labeled a series of numbers X, and in the X I put the numbers 1 through 10. Now let's go over to RStudio and see how that's done. I'll get myself, first I'll get a clean script window, okay? And to get this a new anything, I go up here to the green arrow and I pull down and I'll say I want an R script. And to do the same thing in R, I just say X equal 1 colon 10. And then I could display it. And I'll run all of that. And you can see, yeah, there's X, the numbers 1 through 10. Basically, I did the same thing that I did in Excel. Okay, now what was the next task? Well, let's go back to Excel. We need to get the average value of these things. And in Excel, the mean, type AVERAGE.
Sorry,
And
I'm still not sure about that.
shut up, Siri. Okay, so there I've computed the mean, 5.5. How do I do that in R? Now let's go back to RStudio. In R, what I do is I say mx equal mean of x. And then I'll display mx. I'll select those two lines and I'll run them. And I get the same result that I got in Excel. Okay? So what did I have to do next? Let's go back to Excel. I had to compute the deviation of each one of these values from the mean value. Okay? And I'll take a column over here and I'll label it X DEV for X deviations. Okay? And I create a formula. So equal this minus this. Okay, minus 4.5, and that's correct. 1 is 4.5 below 5.5. Now this formula, what happens if I try to copy this formula down? That's not right. That's not right. What's happened is that I have to be careful with this thing. Excel normally thinks in terms of a relative reference. That is, when you put this formula here, it thinks of this formula as take what is 1 to the left and subtract what is this many down from 1 to the left, okay? So when it goes to compute this, it actually went to this cell rather than to this cell, and when it computed this, it went to this cell rather than to this cell. Well, you can fix that. You can make this an absolute cell reference by putting a $ before the 12, okay? Now we'll get something different, okay? Now we copy this formula down. And okay, now you can see it did everything correctly. 10 is 4.5 above 5.5, whereas 1 is 4.5 below 5.5. Okay? Let's go over and see how we do the same thing in R. In R, oops, I didn't need that. I need to erase it. So I'll create xDEV equals x minus mx. And then I'll display xDEV. And now let me run these two lines. Run. Same numbers, okay. So what did I have to do next? Well, let's see. Next, I had to, if I remember correctly, I had to compute I had to square all those deviations, okay? Well, that's pretty easy to do. Let's go back to Excel. And I'll create another column over here, and I'll just call it xDEV SQ, x deviations squared. Okay, and this is simple because I don't have to worry about absolute and relative cell references. I'll just say what I want in this cell is equal to this cell squared. Okay, and then I copy that all the way down. Okay. Then I have to compute the average of these things. And I do the same thing. I select that range. And the average is 8.25. Okay. And again, let's go back to RStudio and see how I do that over there. Well, over there, I simply say xDEV SQ equals xDEV squared. And then I'll display xDEV SQ. So let's run these two lines, lines 6 and 7. Run them. And I see the same numbers, 20.25, 12.25, okay? You probably remember these same numbers popped up in our Excel spreadsheet. Okay? Oh, and then I took the average. So let's go back to RStudio and let's take the average. And let's see, what will I call that? I'll call that M xDEV SQ equals the mean of xDEV SQ. And then I will display that. M xDEV SQ, the mean of the x deviation squared. And I'll select these two lines and I'll run them. Let's see. Oh, you see what I did? I typed something wrong. It didn't exist because I misspelled it. So now these two lines should work. 8.25, is that the same thing I got in Excel? Yes, it is, 8.25. So now let's go back, and what was the last step? The last step was to take the square root of that. Okay, and the square root of that, that's simple in Excel, it's equal SQRT left paren, this, right paren, and I get this. And now let's go back and do the same thing in RStudio. And I'll say RMSE equals SQRT left paren MXDEV and then I'll display RMSE, oops, the spelling, RMSE, and then I'll run these two lines. Run. Yep, exactly the same number. Okay, so you can see what the difference is between working in Excel and working in R. In R, you write what some people would call code, although there's no really logic to it. It's simply you do one thing and then you do another thing and things get done. The nice thing about code is you could change it, and let's say, suppose I really didn't want to do just the first 10 numbers. Suppose I wanted to do the first 100 numbers. Okay, so I'll change that from 1 to 100. And then I'll just run the entire thing. And I run the entire thing by going up here, Command or Control A, depending on which one you want. Click on Run. And I get the root mean square error of 53.4626. Now, if you want to go back and think about Excel, so what would you do with this spreadsheet now that you've done the work with 1 through 10? How would you use this spreadsheet to do the same thing for 1 to 100 or for any other set of numbers? It's an awful lot more work, isn't it? Also, I've done a fairly decent job of labeling this thing, but if I try to look, if you were handed this spreadsheet and you wanted to look at it and you say, well, what is this? This is B2 squared. Notice that in Excel, things, you don't work with things in a named way. You work with things in a location. So this says take the square of this. You can see that what's happening is that you're always taking the square of the thing to the left. And then where did the thing to the left come from? Well, you can see that the thing over here, the thing in the XDEV column, again, you refer to it by location, the thing one column to the left, minus the thing one column to the left, and down to the 12th position. So this is, it's hard to understand if you come across a spreadsheet and understand what somebody was doing when they created the spreadsheet. In R, code is a little bit unfamiliar, yes, but even though you're not terribly experienced writing, quote, code at this point, you can look at this set of statements in order, and you can see exactly what they did. So that's the difference between R and Excel, and I hope you're picking up from what I say that I don't really approve of doing things in Excel for a lot of reasons. Okay, enough of that for today. So let's wrap this up and save it, and I'll post it. Stop recording.